Okay, so this is first of all an alternating series. So let's check if this is going to be convergent. Okay. First of all, is this here approaching 0? Okay, so this limit of n approaches to infinity and to the power of 4. Okay, this is going to be approaching 0 because of the fact that the denominator at the bottom is larger. Okay, so this is the second test. Okay, so next we want to know, is this a decreasing function? So let's consider f at x, right? X to the power of 4 over 3x to the power of 5 minus 2. Let's differentiate this. And you get 4x cubed differentiate the bottom, we get 15x4. Okay, all squared. So this is 12. So we have 12 minus 15. These are both power of 8, right? So 12 minus 15 is minus 3x to the power of 8, and then minus 8x cubed. So factor out minus x cubed, and you get 3x to the power of 5 plus 8. Okay. Now we're only considering when x is positive here. Okay, so the bottom, right, is equal to 0 at so it's going to be x is equal to plus minus root of 2 over 3. So it's equal to 0 at positive root of 2 over 3, which is less than 1. So beyond 1, right, this is always positive. This is clearly always positive. But this here, right, this is positive. It's negative. So it's positive, positive, positive. We have a negative value here. So that tells you it's less than 0 when x is greater than 1. Okay. So it's decreasing function, meaning the both conditions for alternating series test convergent is satisfied. It's convergent, but is it absolutely convergent? And for that, okay, we need to consider this whole thing. So we need to consider the absolute value of that, which is really just going to be, right? So if I call this whole thing Bn, the absolute value of Bn is this. Okay. Now this is definitely larger. Okay, it's larger than n to the power of 4 over 3 n to the power of 5, which is equal to this. Okay, and we know that the sigma of 1 over n is a harmonic series and it's divergent. And this is bigger than the harmonic series, so this is also going to be divergent, meaning this is conditionally convergent. It's not absolutely convergent for the first one. Okay, so now we discussed everything we need to know about part 1. So what about part 2? Now part 2, you have to consider these two separately. So this is convergent. Okay, this is absolutely convergent by the P series, right? This is bigger than 1, so it's going to be convergent. How about this? So this is actually a geometric series with r being minus pi cubed over 27. However, this r, right, because this is 3.14 cubed over 27. This is only 3 cubed. So this right here is actually larger than 1. So without the negative, it's definitely diverging. Okay, so let's use actually the root test. Okay, so because it's got power of n up here, so it's going to be minus pi. So the absolute value of it, actually, absolute value of our, the general term here. So it's going to be pi cubed over 27, right, to the power of all to the power of n. So we just get pi cubed over 27. Right? So this is equal to L, and it's greater than 1. Right? So therefore, it's divergent. Okay, it's divergent. So we have a convergent plus a divergent. So this is divergent. All right, so let's look at the multiple choice. It's A. It's the first one.